Hi, everyone. Happy Tuesday, and thanks for joining this joint webinar from Check Point and VMware on advanced security for VMware NSX with Check Point. So let's just wait a minute or two until everyone has joined, and we will get started. For those who have just joined, welcome to this joint webinar from Check Point and VMware on advanced security for VMware NSX with Check Point. My name is Jonathan Moreski. I am the product marketing manager at Check Point for CloudGuard IaaS. I am joined by our expert panelists. Stijn Vanveerdeghem is a senior technical product manager at VMware, and Tal Ein-Habar is a cloud security expert at Check Point Software. So please add your questions in the Q&A window, and we will do our best to answer them towards the end of the webinar or offline in the next few days. We are recording the webinar and will make it available to you by email as soon as possible. Now, let's get started with Tal.
Hello, everyone. I'm very happy to participate in this webinar, and I welcome all of you. My name is Tal, and I'm a cloud expert at Check Point Software. And we are going to speak today about the combination of VMware NSX tools with Check Point CloudGuard family. So let's start. First, I want to give you a short brief on Check Point. I hope all of you already knows that, but sometimes it's just good to see it in front of you and get to know the little details about the company. So the company is the global leader in cybersecurity today. We are operating in more than 90 countries, and we are vastly invested in partners. We have a large partners network. Over the last 25 years, we are leading the security or cybersecurity environment, and we are trying to be as innovative as possible and lead that cybersecurity arena. During the last 25 years, we are 20 times the leader in the Gartner Magic Quadrant. We have the highest cyber prevention score on NSS, and we have a bunch of highly rewards and prizes that we won during the years. One thing that I want to mention is Dome9, which got the Gartner and other analyst firms as a cool vendor in cybersecurity, and we just acquired them a year ago, and we are keep developing and investing in that product, and you are more than welcome to go to our site or speak with your Check Point representative to hear more about it. And now I want to give the presentation to Stijn to continue the presentation.
Perfect. Thank you, Tal. So my name is Stijn, and I'm a technical product manager at VMware's Network and Security Business Unit. And in the next hour, we'll talk a little bit about what NSX does, and then specifically talk about our integration with Checkpoint CloudGuard. So you may have heard about the virtual cloud network, and the virtual cloud network is how VMware empowers customers to connect and secure their applications wherever these applications are running. As you all know, in today's reality, applications are not just longer VMs that run on ESXi, but applications can consist of containers, can be partially bare metal, can be deployed on-prem, in hybrid cloud, in public cloud. So the virtual cloud network is how we empower customers to connect and secure all of these applications in a seamless network that is entirely defined in software and extends all the way from edge to the data center, to public clouds, and to the enterprise branch. We support multiple hypervisors as well as various application form factors, as I mentioned, virtual machines, containers, or bare metal. And this allows us to cater to unique networking and security requirements across this wide variety of environments. Now, the virtual cloud network is powered by NSX, and we currently have over 10,000 customers using our virtual cloud network, including 82% of the Fortune 100 customers and 70% of the global telcos. With VMware SD-WAN by VeloCloud, we are also a leader in Gartner's Magic Quadrant for WAN Edge infrastructure. So let's talk about the business issues that NSX solves. We talked about how the virtual cloud network enables a single network and a single security policy that stretches across all of the environments and abstracts the hardware. The automation which NSX provides allows you to spin up a workload in AWS, for example, and make that part of your environment with the same security and networking policies, which enables you for a quicker time to market. And of course, as you know, applications generate revenue, and being able to roll out new applications more quickly enables our customers to generate the revenue of these applications more quickly. Also, if you can consolidate your workloads more effectively and utilize your hypervisor hardware in a more optimal way, there's a significant savings to be made. With NSX, customers can run workloads that belong to completely different networks, completely different zones, or even different tenants on the same physical hypervisors, enabling an increased usage of fewer physical servers with the obvious CapEx and OpEx benefits that come with that. Now, with NSX, we are also delivering intrinsic security that is built right into the hypervisor, as well as in the public cloud, enabling customers to achieve a zero-trust network security architecture across all of the applications, regardless of the form factor of these applications and where these applications or data reside. So let's talk a little bit more about security. Traditionally, security was built around a network topology which didn't change. Back in the day, applications were fairly static, and they were typically confined to one environment. Today, however, as you know, the reality is different. Applications are being deployed across hybrid cloud environments, and this leads to a lack of visibility for the infrastructure admin who's tasked with ensuring the proper security is enforced for all of the applications. At the same time, the automation-driven application deployment models and continuously changing applications have resulted in infrastructure and security teams having to continuously redefine networking and security configurations across various platforms and networks and across various security solutions. All too often, the infrastructure teams and the application owners or developers speak a completely different language. Your application developers often lack proper tools to effectively determine and communicate networking and security requirements for the applications that they're developing. And this leads to long delays in application rollouts, and it also sometimes leads to incorrectly configured policies. And then a last point here is that network-based security policies really lack awareness of the application. But applications that are continuously changing and moving across hybrid clouds, a security policy that is based on static constructs like VLANs or subnets is inadequate, and it leads to an ever-expanding set of firewall rules even after applications have been decommissioned a long time ago. So all of these operational challenges lead to operational inefficiencies and also unmitigated risk, making the job of both the application owner and the infrastructure admins increasingly difficult. So let's talk about microsegmentation. And microsegmentation is one of the key reasons that our customers deploy NSX. To illustrate what microsegmentation is, let me use an analogy here of two ships. One of them is the Titanic. As you all know, it's a very large and supposedly unbreakable or unsinkable ship. However, as you can see from the picture, one breach in the center hull could compromise the entire vessel. And this basically represents your enterprise. Now, a nuclear submarine, on the other hand, is designed very differently. If something gets breached, the breach compartment is isolated from everything else, and the water doesn't compromise the rest of the vessel. And that is exactly what microsegmentation does for your network. It helps you to prevent a breach from laterally spreading throughout your enterprise. Now, while the majority of workloads in and user desktops may be running the latest and greatest patch versions of the applications, the reality is that there's always a number of applications or user desktops that have not installed the latest patches, and those often become the initial attack vector. So without proper microsegmentation, an attack can then spread laterally and immobilize the business or allow the attacker to gain the high value data that they're after. So here's a quick illustration of a basic zero trust model that is enabled with microsegmentation. With a single rule on our distributed firewall, we allow the web server of an application to talk to the middleware, but not to the database server or to any other web server, even if that other web server is physically located within the same VLAN. We can apply a similar rule here to the application server and to the database servers, only allowing them to communicate to and accept communications from the workloads that they should be communicating with. So what enables microsegmentation? This is kind of an overview of the different components in NSX that enable the microsegmentation use case. And if you were at VMworld in San Francisco this year, you may have heard the announcement of NSX Intelligence. This was launched together with the NSX-T 2.5 release, which is our latest version of the NSX-T platform. And the goal of NSX Intelligence is to provide network and security visibility and analytics across the entire environment and help our customers with microsegmentation planning. I'll talk a bit more about that in the next slide. Then also we have cluster management. So our NSX Manager is your single entry point for configuration of the NSX security policy, as well as our network virtualization policy for all of these workloads, regardless of the workloads being virtual machines on ESXi, virtual machines on KVM, containers, bare metal systems, or workloads in the public cloud. All of that is driven from our cluster management system. For those of you who are familiar with our other NSX platform, which is NSX for vSphere or NSX V, you will realize that we've made a couple of very significant changes into the NSX-T platform. First of all of our new feature development is happening in the NSX-T release. And in the NSX-T, we have completely decoupled from vCenter. So all of your configuration is done directly from NSX itself. And it also allows for a far bigger scale. With a single NSX-T manager, you can add in up to 16 different vCenters in NSX-T, while for NSX-V, there was a one-to-one mapping between vCenter and NSX Manager. Then if you look at the actual enforcement level, we have three different components here. First of all, our internal firewall. Our internal firewall is what we call the distributed firewall, and that's basically a firewall that sits in kernel in the hypervisor and sits between the actual workload and the logical switch. So this allows us to apply layer 2 to layer 7 firewalling using application identity to any traffic that leaves that virtual machine, regardless of how that virtual machine is connected. It really doesn't matter from a microsegmentation perspective if you're using network overlays or you're using good old VLANs. And if two workloads are in the same VLAN or a different VLAN, it really doesn't matter because that distributed firewall is applied to the workload traffic even before the traffic leaves or enters the distributed switch. The gateway firewall is the NSX perimeter firewall. So this is deployed on the uplink of a logical router. And this provides your SDDC perimeter firewalling, as well as filtering in between different tenants in your NSX software-defined data center. And then the third component is vendor integration. And this is going to be the topic of today's session. So with vendor integration, NSX has the ability to layer on additional security controls that may not be natively available in NSX. And there's two main use cases here. The first one is what we call service insertion. Service insertion deals with traffic in motion across the network. And this is where we can insert next generation firewall services, such as the CloudGuard gateway. The other use case is what we call endpoint protection. And this is more focused on the agentless antivirus use case. So before I talk more about service insertion, let me just briefly give you an overview of NSX Intelligence. And NSX Intelligence was launched at VMworld in San Francisco this year. This is part of the NSXT 2.5 release. And NSX Intelligence is our distributed analytics and visibility platform that is fully integrated into NSX. So the goal of NSX Intelligence is to provide visibility into flows across the entire environment, and also to aid in microsegmentation planning. When it comes to microsegmentation, the goal of most of our customers is to get to a zero trust architecture in which they only allow the flows to and within the application that are required for the application to function. In order to do that, you need to understand the application well. You have to profile this application. And NSX Intelligence takes the manual work of application profiling out of the equation and automates that process by automatically providing the recommended microsegmentation rules. So unlike other platforms out there, NSX Intelligence does not require you to send a copy of all the packets to a centralized appliance. It also does not require NetFlow or IPFix. Instead, NSX Intelligence uses the distributed architecture that we already have with the distributed firewall sitting at the VNIC of every virtual machine in order to send metadata of every flow to our centralized appliance. So this heavily reduces the amount of traffic that needs to be sent to a centralized appliance, allowing us to deduplicate flows right at the source before sending it to our centralized appliance. Of course, with NSX Intelligence, you can see a complete overview of the flows, and you can also dive deep into specific flows. We don't just gather information from the network, but we also integrate with our input information. For example, for any workload that runs VMware tools, we are able to get detailed information about the actual operating system and about any process that is running on that particular workload. So that was NSX Intelligence, and the reason I wanted to show that is because that was our biggest announcement at VMworld in San Francisco this year. Now, covering service insertion, which is going to be what we'll do for the rest of the session today. The goal of service insertion is to layer on additional security controls or enable customers to add on these additional security controls within the NSX SDDC. Service insertion specifically deals with data in motion across the network. And in NSXT, there is two ways that we can insert third-party or partner security controls. One of them is at the perimeter, or what we call north to south service insertion. The other one is called at each workload's VNIC, or that's what's called east to west service insertion. So the perimeter service insertion use case really aligns with the NSX gateway firewall. So this is where we can insert these additional security controls at the same level at the gate of the gateway firewall. And then east to west service insertion, this aligns with our distributed firewall. So this is where we can insert additional security controls, such as the Checkpoint CloudGuard gateway, right at the VNIC of every single workload. The main use cases for service insertion is for security and visibility services. So of course, security such as the Checkpoint CloudGuard, next generation firewall, IPS, IDS, URL filtering, all of these services. The visibility use case is for traffic aggregation. So instead of actually redirecting our traffic through a third-party appliance, we can also send a copy of our traffic to a third-party partner appliance for traffic aggregation or network and security analytics. In NSXT, we also support service chaining, which allows customers to chain multiple services after each other. For example, depending on the security requirements for your PCI zone, for example, you may be required to ensure that all traffic going into your PCI zone passes through an IDS solution, and then also is sent through another network monitoring appliance, potentially for analytics or for lawful intercept, for example. We also support a consistent policy across multiple vCenters, and this is really due to the architecture of NSXT, which is decoupled from vCenter, and it allows us to add up to 16 vCenters into one single NSXT manager and create a native network and security policy that spans across the 16 vCenters. The same is also true for service insertion of our partners. So you can have a single policy on your Checkpoint CloudGuard manager that stretches across these the workloads that belong to 16 different vCenters. And we also provide deep integration with partners, and I'll talk a bit more about that later, but it's not just about redirecting the traffic to a third-party appliance. There's a whole lot more than we can do that we do than just that redirection. And what are some of the common services that are enabled by service insertion? You see them here. So of course, we have our core micro-segmentation, which are services natively provided by the NSX distributed firewall and gateway firewall. And then on top of that, customers can choose to layer on these additional security controls from our partners. So the goal of NSX, of course, from a security perspective, is to be able to provide consistent security and consistent visibility across all of the workloads, regardless if these workloads are on-prem or in the public cloud, regardless if they're VMs, containers, or even physical servers. And we have our distributed firewall, which is the icon in green here, the firewall icon, which is deployed to the VNIC of every workload. We also have our gateway firewall, which is applied to the uplink of a logical router. And then we have our north to south service insertion, which is applied to that same location, the same uplink of a logical router. This is the ability to selectively redirect traffic to a partner next generation firewall. The same service insertion here is available directly at the VNIC of a virtual machine. So once traffic passes through the distributed firewall, we can then selectively redirect certain traffic to a partner firewall appliance. So I mentioned with NSXT, we provide deep partner integration. And what does that really mean? What are the benefits of that? First of all, we provide granular service insertion. And this means that with the same granularity that you have the native NSX security controls with the distributed firewall that sits at the VNIC of every single workload, you can also selectively apply service insertion. So you can be very selective and create a policy that, for example, only your traffic from a specific tenant or your traffic in between tenants or traffic going into a particular zone in which certain compliance requirements need to be met, only that traffic should be redirected to a third-party appliance. We also provide simplified provisioning. That is, and you'll see that in a demo that I'll do later on as well, but basically you register the Checkpoint CloudGuard service or any of our other third-party partner services with NSX that makes the service available in our catalog, and NSX then handles the lifecycle management of that third-party appliance. We can automatically deploy your third-party service virtual machine, effectively your gateway appliance, anywhere that you want to deploy that. And if you add a new host into your environment, we can also automatically deploy a new service machine on that particular host. We also automatically take care of the plumbing. So we create the appropriate overlay logical switches, the appropriate networking in order to plumb the partner next generation firewall into the NSX environment, enabling us to steer traffic across that network segment to the partner appliance. A third benefit, and this is really a very important one, is ubiquitous application-based policies. And this is where, with NSX itself, on the distributed firewall, you can create firewall policies that are independent of IP addresses. And you do that through something called security groups. And a security group is really a logical grouping of workloads that belong together and that need a similar security policy. It could be your PCI workloads, or it could be the application tier of an application. You can, for example, apply a security tag to a particular workload to identify that this workload is deployed in production, or to identify that this workload has to meet PCI compliance, or identify that this workload is the web tier of a particular application. Then based on these security tags being applied, a workload becomes a member of a specific security group, and a policy is applied to that security group. We also share these security groups with our partners, and this enables you to, on the Checkpoint gateway, also create a policy that leverages the same security groups independent, or and really make sure that you don't have to create a policy that is based on static IP addresses, and you constantly have to change whenever you deploy a new application or whenever you make a change to IP addresses. We will automatically push the updated security groups whenever an update happens. For example, a new application is deployed, you apply the appropriate security tag to that application. As a result, the application becomes part of a security group. We will then automatically push the IP address of that, the updated IP addresses of that security group also into the Checkpoint manager. We support flexible and scalable service chains. As I mentioned, customers can be very selective and choose what particular services should be applied to what particular flow of traffic. So there's a lot of granularity here. You can choose to just apply the Checkpoint CloudGuard service, or you can choose to, for certain flows, to redirect the traffic to multiple next-generation firewall solutions for defense in-depth, or to a next-generation firewall and network monitoring appliance, for example. And then, as I mentioned, we provide consistent policy across up to 16 vCenters with NSXT. So now let me talk a little bit about the service consumption workflow. And in NSXT, this is the same workflow for both north to south and as well as east to west server insertion. I'll talk a little bit more about north to south and east to west. And this also applies to the endpoint protection use case, which enables agentless antivirus. So a very, very similar deployment workflow to enable simplicity when it comes to applying the appropriate security policy. So the first thing that you will do, and this is driven really from the partner, so this is something that you will do from the Checkpoint manager, is actually create a service and register that service with the NSX manager. Once you've done that, the service becomes available in the NSX manager UI. And then the next steps are really driven by the NSX admin. And this is the same across all different partner solutions. So it doesn't really matter if you're deploying a Checkpoint CloudGuard or you're deploying any of our other partner solutions. The workflow here is exactly the same, in the sense that the NSX admin will consume the service from the catalog and choose where to deploy the service, and then what traffic should be redirected to that particular service. The final step is service consumption, and this goes back to your Checkpoint CloudGuard management platform. And this is your smart console, and this is where you effectively create your checkpoint policy and define threat prevention or the appropriate firewall policies on the checkpoint side. So I mentioned in NSXT, we support north to south as well as east to west service insertion. The goal of north to south service insertion is really to protect the perimeter. And this could be the SDDC, your data center perimeter, by applying service insertion at the uplink of an NSXT logical router. The logical routers in NSXT, for those of you who are not familiar, this is what enables our overlay networking. And this is not required. So, some of our customers across both NSXT as well as the NSX for vSphere platform use their existing VLAN-based network connectivity and use NSX only for the microsegmentation and service insertion use case without requiring these logical routers. That's entirely supported and possible as well. But if the logical routers are used, they provide our inter-tenant routing with our T1 or tenant router and perimeter routing with our T0 or our provider router. And applied to the uplink of these logical routers, we can selectively redirect traffic to a Checkpoint CloudGuard appliance. So this enables us to provide additional protection to the SDDC perimeter, in addition to what the NSX gateway firewall by itself already provides. It allows us to protect the tenant provider perimeter, also Kubernetes namespaces. If you're using containers and with multiple namespaces, traffic that goes between these namespaces also passes through a logical router, and we can selectively intercept the traffic and redirect this into the namespace traffic to a CloudGuard appliance. We can also protect native public cloud workloads by deploying a Checkpoint appliance in the Transit VPC, and we support active standby in this use case. So if a primary Checkpoint appliance or partner appliance would fail, we can then redirect the traffic to a standby appliance that is automatically deployed and for which we handle the lifecycle management through NSX. Those of you who were familiar with NSX for vSphere, you realize that this north to south server insertion is completely new, and this did not exist with our previous NSX for vSphere release. This only is available and only will be available in NSXT. And that brings us to the east to west service insertion use case. So east to west service insertion is really service insertion applied at the granularity of every single workload. So it doesn't matter if that workload is a virtual machine or a container. At the VNIC or the container interface of that workload, that traffic passes through our distributed firewall, and then we can selectively intercept the traffic and redirect the traffic to a third-party appliance. So that, of course, enables us to protect communication between different virtual machines, regardless of these VMs being in the same VLAN, in a different VLAN, in the same overlay segment, or the different overlay segment, because we're able to intercept the traffic and apply security before the traffic ever hits our switch. It also provides intra-container communication security. And then with NSXT, we provide two different deployment options. And I'll talk a bit more about that in the next slide, so I'll skip that for now. We provide service chaining, which is the ability to provide or apply multiple services to a particular flow of traffic. We support up to 16 vSphere into one NSX manager. And we also support guest vMotion. So if a particular workload here vMotions from one host to another host, from one cluster to another cluster, the NSX distributed firewall policy, as well as the actual flow table, move right along with that virtual machine to its new destination. And we will also ensure that traffic keeps being redirected to the same Checkpoint CloudGuard gateway. We also support load balancing across multiple service instances. So if you need a lot of traffic to be redirected to a Checkpoint CloudGuard, we can load balance all of the traffic across however many Checkpoint CloudGuard instances you have deployed in your environment. And we support standards-based packet delivery. So for those of you who are familiar with how we did service insertion in NSX for vSphere, in TD architecture is quite different. For NSX for vSphere, we basically required a service virtual machine to be deployed on every single host in a particular cluster. That, of course, can get quite expensive from a licensing point of view. Also, in NSXV, we were using what we call a shared memory channel, or the VMCI channel, in order to share packet data with our partner service. The drawback of that model is that it's rather challenging for our partners to finalize the integration. It's a lot of very specialized work they had to do for us. And in NSXT, we chose for a different model, and instead of using a shared memory channel, we are actually using a standard-based protocol called the network service header in order to deliver packets to our partner appliance. And that enables us to not just deliver packets locally to a service virtual machine that is deployed on the hypervisor itself, but it also allows us to deliver packets to a Checkpoint gateway appliance that is deployed somewhere else in the network, that is deployed on a different hypervisor in the network. So that brings us to these two different deployment options that we support with NSXT. First, the one on the right, and this is similar to the deployment options that we supported in NSXV. That's what we call local or host-based deployment. And this is where you deploy an instance of your CloudGuard gateway or whatever partner service that you're deploying. You deploy that on every single compute node in your cluster. So these are the compute nodes where you host your applications. On the same compute nodes, you can deploy a Checkpoint CloudGuard appliance. So similar option, similar deployment model to NSX for vSphere. Now, the other deployment option is the cluster-based deployment option. And in this option, we're not deploying any CloudGuard appliance on the compute nodes where you have your hypervisors. Instead, we are deploying these CloudGuard appliances on a separate service node. And we then redirect the traffic. We have the ability to redirect the traffic that needs to be inspected by CloudGuard across our overlay network to those dedicated to that dedicated service node, which runs the CloudGuard service virtual machines. So the benefit, of course, of this model is that it gives you a lot more flexibility. In a sense, you can choose what is the amount of Checkpoint CloudGuard capacity that you need, and you can then deploy the appropriate number of CloudGuard appliances on a service node. The drawback of this model, of course, is that you are sending the traffic across on the physical network, while with the local cloud host-based model, all the traffic that needs a particular service here stays locally within the hypervisor. And with that, I'll hand it off to Tal to talk a little bit more about some of the specifics of our integration with CloudGuard.
Thank you, Stijn. So let's talk a little bit about CloudGuard. We are talking about CloudGuard IaaS, infrastructure as a service, and with this product family, we can protect with the same security capabilities and with the same security method all over cloud environments, whether they are private or public, or of course, as we are speaking right now, the NSX, both the V and the T, both of them. And with those things, we are on each platform support the available deployment method. For example, the host-based or the cluster-based that Stijn just spoke about. For each of these, by the way, we have a documented best practices for you to start working with and easy entrance into that world. So let's talk about CloudGuard and NSX. What do we support? How do we support it? The first thing that we are able to do is provide advanced threat prevention to the microsegmentation that Stijn spoke about. You can take your environment, your data center, and break it into small pieces and deploy a checkpoint CloudGuard logically in between. And that way you can bring all the advanced threat prevention into your data center and into your cloud environment and inspect traffic that travels between those security groups. The second thing that we are providing is automation. Automation today, especially in the large environment, is very, very important. It enables you to be more efficient, more flexible about your environment. And with the CloudGuard, we are enabling you to deploy the checkpoint gateways via the service registration that Stijn spoke about. But above that, we are enabling you to inject security rules and security definitions into the checkpoint policy. So while you are deploying your application with Terraform, Ansible, vRealize, or any other orchestration platform, you can inject the rules and see all the logs from one place, either manually or via fully automated service. We are also allowing you for those services to control only part of your security policy, which means if you are now giving the ability to an automated user via the orchestration platform to change your policy, you are sure that it won't mess up your entire policy, but mainly those 1, 2, 3 rules that you're allowing him to play with or change. The last section is unified management. Checkpoint has one unified management, the management console, and it applies and manages all of Checkpoint appliances, whether they are physical, virtual, or cloud gateways, just like in the NSX use case. And the policy is consistent and applied on all the gateways altogether. And this one allows us to create an effective north-south and east-west traffic control with our security policy and security appliances. Our gateway is very similar to the physical gateway, which means we have all the security capabilities except for the physical appliance, which means all the security engines that you know, whether they are content awareness, anti-bot, threat extraction, threat emulation, of course, the firewall, the IPS, and all the award-winning security engines are applicable to the NSX protection as well, with R80.10 and 20 in the future. We also have the ability to connect our security gateway with the threat cloud. The threat cloud is our threat intelligence cloud that receives information for more than 100K users or customers and appliances, which feeding in information about things that they have found in the network, but it also allows us to feed those appliances, the checkpoint appliances or checkpoint products, with information that we are seeing or risk that we are seeing in the field. We are receiving about 86 billion transactions per day. We have more than 4 million files we are emulating per day. And we stopped a lot of zero-day files per day, which is quite impressive, and it's the largest cloud of its kind. Let's talk a little bit about the checkpoint security capabilities. And as we can see, the main security engines, not all of them, are listed on the left of your screen. And you can see that the upper 4 are relevant both to east-west traffic control and to the north-south. The lower side is more applicable to north-south traffic control because they are dealing more, not necessarily mandatory, to the north-south, to the user experience. When users are receiving files or sending information in and out or accessing the network. Now, VMware has several security features of their own, which are pretty good, but they don't have the full stack as we do. When we are talking about orchestration or vRealize orchestration, we mean that we're not dealing only with NSX. The combination together of VMware from one side and Checkpoint CloudGuard from the other side, we have a very big cooperation, and we are working together through the entire portfolio, whether it's the mobile environment or in this case, the orchestration. So we can work, of course, with Terraform, Ansible, or any other orchestration that you're working on, but we are working with vRealize for several years now, actually almost from the moment it's been launched. And by using that ability, we can automate processes like deploying a new CloudGuard instance, provision new security rules, install policy, creating log, import security groups, and many more options. Through our management, we want to be able to create an application-aware policy. And why is this? Our policy is changing all the time. If we two clicks of a button, we can launch a new VM or a new container on the NSX-T or on the NSX-V with the ESXi or any other virtualization platform. We want to be able to know what happens in our environment and change our security policy the moment it happens. We don't want to be creating the application via an automation platform or manually, and then needs to open a ticket to the security team and wait a few days for them to open the rules. We want it to be instantly, and we want it to be as correlated to with the application deployment. So what can we do with the CloudGuard Adaptive Security, which is the CloudGuard controller, which is part of the security management platform? It's a free of charge feature on our security management platform. And what it enables us to do, it enables us to take objects from our environment, cloud environment, of course, whether it's NSX-T and V security groups, whether it's AWS tags or Azure VNets, and combine all of it together to a single policy. Now think that you have two NSX-T deployments, one in each region, one in each site that you have, and you want to connect between them. You have one management security policy, unified security policy, that enables you to create a security group from one side can speak with security group from the other side. Which machines are included in those security groups? Who cares? It changes all the time. It's automatic. But the fact that I'm creating that object or that policy one time and it fits itself all the time, this is the great power, and this is the huge advantage and the huge capability from the checkpoint management. Stijn talked about the service deployment options. And as you can see, we are supporting both the on-host environment, NSX-V or NSX-T, or the clustered environment, which we have a service cluster for CloudGuard IaaS gateways, and we can insert those gateways into the security policy. We can also communicate and perform the service insertion on the edge routers to be able to catch malwares entering or leaving the data center. And this is just an example of the anti-bot. We have a VM with a bot inside. It's trying to communicate with this operator outside, command and control server. It goes to the external router. The router is diverting or service inserting the CloudGuard gateway into that flow, and we are catching that flow and blocking the traffic. Another method is the IPS. And from here, we can see it in the service cluster. And once the packet is leaving the web server, it catches the VM or NSX is catching that packet, that flow, and redirecting it on a different separated network to the CloudGuard gateway, the relevant CloudGuard gateway. It gets examined, and then it moves back into the relevant VM destination. Stijn mentioned earlier the zero trust model. And we've seen that the service insertion is being done by the NSX. And the NSX firewall is basic part of that service insertion process. So where do we keep the security policy? Do we keep it on the NSX, on the NSXV, on the CloudGuard? So we can work in parallel, that everything goes through the NSX and leave that configuration quite open and make most of the security on the CloudGuard, or how most of our customers are working, we are doing it simultaneously. Some of the traffic that needs some protections are going through the NSX firewall and bypass the Checkpoint CloudGuard, and some of the traffic are going through the CloudGuard, depends on the sensitivity, depends on the environment, and that means that every customer is fitting that model to his needs. Both ways are applicable and both ways are working fine, and you just need to choose and fit it to your needs. There is no one size fit all. Every company is doing what's best for her. But we all support it together, VMware and Checkpoint together. And then we are coming into PKS. And PKS, from our point of view, is just another machine on the network. Once the PKS is part of the NSX environment, we are seeing it as a security group. We are seeing it as a machine on the network, and that way we can control it just like we are controlling any VM. So from our point of view, it's just another VM on the network, and all the integration behind is done by the NSX. We can also support VMC. VMC on AWS, we can connect it. For those who don't know, its ability to strengthen or take part of the NSX environment and put it on AWS. And on AWS to deploy a gateway, NSX gateway, which acts like the NSX router inside your on-prem environment. And of course, we are supporting that. This is how it works. Actually, all the traffic is coming from the VNet or the VPC, depends on the platform you are working on, to the NSX gateway. The NSX gateway is doing service insertion with the CloudGuard gateways that are deployed natively on that cloud environment, cloud provider environment, whether it's Azure or AWS, and allows us to be part of that service insertion, although everything is managed by the NSX. So what do we have? What do we need in order to communicate or build Checkpoint CloudGuard IaaS into the NSX or NSXV solution? We have the gateway or gateways, depends on the way we are working, on host or clustered. We have the manager, the Checkpoint manager, the SMS or the CMAs. And we have the user interface, which is the Smart Console. It's deployed on a Windows machine where you can configure and manage all the security policy. And with that, I'm moving the stick back to Stijn to continue the presentation.
Perfect, thank you, Tal. So I'll do a quick demo here now about the integration between NSXT and Checkpoint CloudGuard Gateway. And this is a demo really of an on-prem environment. And in this environment, the demo, you'll see that I have two different three-tier applications. There's an MRS or a medical record application, and then there's an HR management or HRM application. I've already, for the purposes of this demo, I've already micro-segmented these applications. So I've already used the distributed firewall to first of all isolate both of these applications from each other, and then secondarily, I've created an NSX distributed firewall policy to ensure that we only allow traffic from the web tier to the app tier here on the relevant port that the application tier is listing on, and same for the other tiers and the other applications. But there is an additional requirement here, and the requirement is that any data or any application that has been classified as private, for any traffic that deals with those applications, that traffic should also be redirected to a CloudGuard gateway in order to apply basic threat prevention. And for any traffic that deals with restricted data, that traffic should not just be redirected to CloudGuard to apply a strict IPS profile, but that same traffic should be, or a copy of that traffic should also be sent to a network monitoring appliance in order to get a record of all of those flows. So that's, in this demo, you'll really see the benefits of using service chaining, in which we can selectively apply a different set of services based on the requirements. So the first thing that we have to do in Checkpoint CloudGuard here in order to use service insertion is register Checkpoint Manager with NSXT. And the way that we do that here from the CLI, I'll kind of go over that quickly, but we basically just tell Checkpoint Manager, where is the NSXT manager? You can see in this case, there's two different NSXT managers in my environment. We select the appropriate NSXT manager that we want to register the service with, and then we need to specify a few parameters, like what is the OVF path to the actual CloudGuard gateway image that will then be deployed by NSXT. So we provide those details, as you can see here. Once we confirm the details, and the service will then become available in the NSXT Manager catalog. So when we go to our catalog here, you can see that the CloudGuard IaaS service here has been added and is now available for deployment. So the next step, we can then choose to deploy that service. So here, our NSX admin supports or selects the CloudGuard IaaS partner service, and here then specifies how this IaaS service should be deployed. And in this case, because we need to apply a differentiated IPS policy to two different applications, depending on the data classification level, we are using what is called east to west service insertion. So this allows us to insert Checkpoint CloudGuard in between flows that stay within the data center. So in between the application tiers for our two different applications. So here we can specify all the required parameters. We give our service a name. We choose, do we want to do the host or cluster-based deployment option? And Tal and myself, we talked about these different options. You either deploy the service virtual machine on every single compute hypervisor, or you deploy it on a dedicated service node and then redirect the traffic across the network. Once you selected your deployment type, you then select the actual cluster, the actual vCenter cluster where you want to deploy your CloudGuard service virtual machine. And the next thing that you do here is really select what are the number of instances that you want to deploy. So this is where the service scaling comes into play. Is depending on how much throughput capacity that you need on your CloudGuard appliances, you can choose to deploy a specific number of CloudGuard appliances. If you run out of available capacity, you can add in additional service virtual machines to your cluster at any point in time in the future as well. Once we've configured everything, we can save that, and this is automatically going to start the deployment process. So now you can see when we look at service instances here, you can see that two service instances of the CloudGuard East to West Gateway are being deployed. And this calls a vCenter API in order to deploy those OVFs with the file location that we specified earlier. So you can see here that our two appliances have been deployed. And you can also see that both of these CloudGuard appliances have been connected into our overlay service segment. So we automatically plumb them into a service segment, and that then allows us to steer traffic across that overlay segment to the partner service without you as a customer having to make any manual network configurations. All of that happens, is automated through the service deployment, service insertion process. So then we can go back here into service instances and confirm that both of our service instances here are up and running. And as you can see, that's the case. We can look at the runtime status details there if you want to do that as well. Now let's go to Smart Console, and you can see that in Smart Console, both of the east to west service virtual machines here have been added. These are added automatically. The next thing that we can do is, in order to use those dynamic NSX security groups, which enable a policy that is independent of IP address, which enable a policy based on security groups, we can add NSXT Manager here into Smart Console. So we select NSXT here as a new object and configure your NSXT parameters. Once we've done that, we can then create an appropriate policy in CloudGuard that is based on NSX security groups. Now, before we do that, we can actually consume the service now in NSXT. And the first thing that we have to do here is create an appropriate service profile. So our CloudGuard IaaS service VMs have been deployed. Now we have to choose how do we actually redirect traffic to these appliances. In order to do that, we create a service profile, and this just defines how do we want to redirect the traffic to this particular instance. If you have multiple tenants, for example, you could provide, or you could define multiple service profiles here and apply a different policy in the CloudGuard Manager to these different tenants. So we can save that. And then I mentioned for traffic in the restricted applications, we also have a requirement that traffic is redirected to a network monitoring appliance. So this could be another third-party appliance that delivers or that sees a copy of the traffic in order to provide analytics or traffic aggregation. So for that, we've also created a service profile. And in this case, we're copying the packets instead of redirecting the packets to those appliances. Then the next step is creating a service chain, and this really defines for both the private and the restricted data classification levels what kind of services need to be applied and what is the order of the services. And first of all, here for private, we just apply the CloudGuard gateway firewall. We also create our failure policy. Now for the restricted classification level, here we need to redirect traffic both to CloudGuard and then also to our network monitoring appliance. So we select CloudGuard, we select our network monitoring appliance. We can change the ordering of the services here if we want to do that. First send it to CloudGuard, then network monitoring, and then save. And that pretty much is there's only one thing left in configuration to do here, and that's creating the actual redirection rules, which specifies how traffic is actually redirected to our partner service. And in this case, we have, again, our restricted applications, which are applications that deal with restricted data. And then we have our private applications. And we apply the two service chains that we defined earlier to traffic coming in and traffic in between workloads for each of these classification levels. Also, we can have a look at the membership criteria here of this production private security group, for example, and you can see that our HRM application workloads became a member of this particular security group, and they became a member because we had a security tag applied to these workloads that identifies that those workloads are part of the HRM application. We can also have a look at the group definition here. Again, we're matching the HRM application tag. And as I mentioned, we share these security groups also with the checkpoint manager. So also when we look at the restricted applications, similar policy here, but in this case, we are applying the restricted service chain, which redirects traffic to the CloudGuard appliance, the CloudGuard gateway, and then sends a copy of the traffic to another third-party network monitoring appliance. Okay, so now let's test our application here just to generate some traffic. And we're doing that here. Our application is working, and then we can go into Smart Console. And here we have our policy applied. So we can have a different policy applied for a private and restricted applications. And when we look at the members of these security groups, you can see for private, you can see the IP addresses here of our workloads. And with the security group sharing in NSXT, we automatically add the IP addresses there for those workloads. So this is done behind the scenes. We automatically update to CloudGuard. And you can see that our rules are being hit here as well. You can see traffic coming into our HRM application. And then finally, we can go into our threat prevention policy here on Smart Console, and we can apply a different threat prevention policy to the restricted and private applications. And as soon as we do that, you can see now that we have IPS signature here for a directory traversal between the two different web applications is already firing. And that is the end of the demo. Tal, back over to you.
Yes, so we have 1 minute left, and we want to expand that webinar a few moments in order to be able to answer some of your questions. So just the last slide, I want to mention that we are working together, and together we are able to deliver advanced threat prevention to the SDDC. We are providing security. We are fully integrated with NSX and vCenter and vRealize. So the companies are working together to deliver auto provisioning, auto scaling, auto remediation, and everything that we can deliver in an automated way, we will try to do so. We have the dynamic nature, which allows us to import security groups and tags from the NSX platform into the checkpoint security policy in order to make it a whole and adaptive and adapt the changes that happens to the application into the checkpoint security policy. And last but not least, we have a unified management which allows us to be able to control all your cloud gateways and physical appliances all together. The last thing I want to show you is this documentation site. You can see that link. You can go over it when you will get the recording of the session. And here and now we will answer a few questions. Jonathan, can you ask some of the questions?
Yeah, thanks. So we got a huge amount of questions during the webinar, many more questions than we can answer. So we will answer all the questions that we can, but any questions we don't answer, we will answer by email offline after the webinar. And thanks again to Stijn and to Tal. It was very valuable. So the first question goes to Stijn. If we have multiple ESX hosts, where do we do service insertion to redirect traffic for inspection to the service VM? Is it to all the hosts or to any one of them?
Yeah, excellent question. So, with NSXT, you really have the flexibility to choose what traffic is redirected and where it's redirected, right? So you can deploy the CloudGuard appliance on every single host in a particular cluster if you want to do so. And then the traffic gets redirected locally to the local instance of that checkpoint CloudGuard. The other option is what we call the cluster-based deployment, and this allows you to deploy the CloudGuard appliance centrally on a dedicated cluster and then select traffic from workloads from particular hosts if you want to do that. So you really have the flexibility. You can do it on a per host basis, on a per cluster basis, or you can deploy a centralized appliance, and then you really have the granularity of a redirection rule and can be as selective as you want to be. So you could theoretically say that only traffic going into one particular VM should always be directed to a checkpoint, or you could be much more broad and say that any traffic coming in my web tier, for example, or my entire environment should be redirected. So you have complete flexibility there.
Thanks, Stijn. A question for Tal. Can CloudGuard see each container node inside the PKS as a separate machine and apply security rules between different containers?
We are seeing the Kubernetes machines, the containers, as a sort of VMs on the network. So as long as they have the tags, the relevant tags, or the security groups attached to them, we can deal with them and do security policy between them. But if you don't provide the tags or the security groups, we can't deal with the security configuration, and you need to do it inside the NSX firewall.
Okay, another question. Is there any way to register the checkpoint physical like a VSX, where each time the virtual system is created?
No, this is something that can't be done. The deployment is done automatically by the system. Once you are launching a new host, if you are working on hosting deployment, or if you are doing a service chaining, you just add another checkpoint CloudGuard gateway into the service chaining.
Yeah, what I would add to that as well is that, yes, definitely the service VM that we automatically deploy, to which we can redirect the traffic, that has to be a virtual machine because NSX handles the lifecycle management. NSX also provides liveness detection and a couple of other functions. So that's why it's somewhat tightly integrated with NSX. However, using your Checkpoint Smart Console, when I was showing that integration with security groups, that you can use these NSX security groups in your CloudGuard policy, those same security groups could also be applied to a physical checkpoint appliance that is sitting somewhere at your perimeter.
Okay, so we're going to take one last question. It's from an anonymous attendee. How many service VMs can you have per ESXi host? And can you have more than one service VM where each supports a tenant?
Yes, so you can have up to 8 service VMs per in the cluster mode per ESXi host, and you can definitely, in case of north to south server insertion, if you apply north to south server insertion to a tier 1 or a tenant rather, you basically have your service VM on a per tenant basis. If you're using east to west server insertion, you can absolutely also deploy a dedicated service VM to a dedicated tenant, and then redirect the traffic in your redirection roles. Basically, create 2 different service chains: a service chain for tenant 1, a service chain for tenant 2, and redirect the traffic for tenant 1 to the tenant 1 checkpoint SVM. Redirect traffic from and to tenant 2 to the tenant 2 checkpoint CloudGuard. Definitely possible.
I'm going to take one last question. So are the CloudGuard gateways in per host setup still dependent from the ESXi cluster object? Do we have a checkpoint cluster object for that with a virtual address?
Currently, we don't have any cluster object for that. This is something that is being considered. Currently, it's just like before, something very similar to the NSX-V that we are supporting. So we have a cluster object, but each of the gateways is handling by itself.
So guys and everybody else on the bridge, we're a little bit over time. I'm going to take all the questions, put them all together, get them answered by Tal and by Stijn. We actually had a request that we send all the answers to all the questions by email to everybody, and I think that's a great suggestion. I have to say that we were very impressed by the number of participants or people on the call, and by the number of questions. I really appreciate it, and I think perhaps this is a good opportunity for us to do maybe a follow-up webinar in the next maybe just after the new year, that we can have some time to set it up and schedule it. And thank you again for your participation. We really appreciate you being on board, and we look forward to working together to improve your cloud security. Please contact us at Checkpoint and VMware with any following questions. And thanks again to Tal and to Stijn. We'll be sending the webinar recording in a few days' time. Thank you, everybody.